This video deals with the design and installation of an electric propulsion system on a small sailboat. The boat is a Catalina 275 Sport, which is 27.5 feet long and weighs about 5,000 pounds. So the components that were selected to use in this system, are suitable, for that size boat. So it should be noted that this particular sailboat is located on an inland lake, a fairly small inland lake that's about 10 miles long, and so the amount of battery capacity, that was selected was suitable, for that location. If you were somewhere with a larger lake or, on a bay or something at the coast, you might want, a higher capacity battery and or a higher capacity motor. So anyway, this is for this project, I selected electric propulsion equipment vendor, ePropulsion, for the system. It was just the products that they had, were a good match, and the reviews indicated it was high quality, reliable equipment. So the main drive is the electric drive is ePropulsion Pod 3.0, which is a 3,000 watt output or 6 horsepower equivalent. The battery is a ePropulsion E60, which is a lithium iron phosphate battery with a capacity of 60 amp hours. It has the pod comes with a driver module in the box, and then the battery charger that I selected is the ePropulsion E series battery charger. It's basically just 120 volt. They make one that's 240 volt for European power systems. And the controller that I selected is the ePropulsion side mount controller, as opposed to the top mount that they also offer. And then I got a remote battery switch so that I didn't have to go into the compartment, to turn on and off the battery all the time. I could just open the hatch and turn the battery on or off using that remote switch. So this is the Catalina 275 as we received it, without any kind of propulsion system or outboard motor bracket. This layout of the Catalina 275 shows where the ePropulsion equipment is going to be installed. This is a picture from the ePropulsion literature that shows how the pod connects to the driver module and the battery and the comms cables, the charger connection, etc. This is the equipment arrangement sketch for location of all the ePropulsion equipment, in the equipment compartment. The battery, the driver module, where the pod comes up, the vent fan, and even the battery charger shown on the back side of the bulkhead behind the compartment. This shows what the pod drive 3.0 looked like when we opened the box. This is what they call the driver module, and that connects to the pod drive and to the actual battery. This is a view looking aft on the starboard side, where a lot of the equipment was going to be mounted for both the shore power system, which isn't covered in this video, and the on-off switch, which is covered as part of the ePropulsion. This shows the equipment bay where there's a CUSA board, which is a 1/2 inch thick, and glued two 1/2 inch thick CUSA boards, with epoxy to make a 6x12 reinforcement for the hull to make it stronger where the pod drive mounts onto the bottom of the hull. This is what they call the fixing guide that ePropulsion provides, with the kit. And so the orange color numbers and stuff are the dimensions for the pod 3.0. Here I am drilling a 2-inch diameter hole up through the bottom of the hull. You can see the other holes for the bolts, the 3 bolts that hold the pod drive in place, and I drilled a 1/8 inch diameter hole up through where the larger hole would be, and so I could see where that came up through the hull through the CUSA board that's in the equipment bay. Here you can see more clearly where I've drilled through the fiberglass of the hull but not drilled through the black CUSA board, and you can also see the other mounting holes for the pod drive. This view shows where the battery charger is going to be mounted just aft of the equipment bay on the other side of the bulkhead, so that the heat off the battery charger will be discharged away from the equipment compartment. In this view you can see where the chalk that gets shaped conform to the bottom of the hull has been put in, and then the pod drive has been bolted up to the hull with adhesive to seal it off. This is just another view of the pod drive mounted on the bottom of the hull. And I'm happy to say that once the boat was put in the water, there are no leaks. Here's a view of the battery charger mounted on the aft side of the bulkhead, just to the aft of the equipment compartment, and you can see the driver module on the right there. So this battery charger will generate a lot of heat when it's on, and it'll only be on plugged in at the dock. So this way the fan that's on the battery charger will dissipate the heat to the rest of the boat. This shows the vent fan. It's a 12-volt vent fan that 3-inch diameter that's installed in the equipment bay. To the left is the discharge hose that pushes all of the ventilated air back into the compartment on the back of the boat. This view shows the throttle and the display mounted on the starboard side of the cockpit area. This is a sketch or concept of how I would tie down the battery. I wanted to make chocks so it couldn't move around laterally, and then I also needed to tie it down so if the boat should turn upside down, that the straps would hold the battery in the proper position in the engine or the equipment compartment. This shows the equipment compartment with the battery tie down chocks, which I just cut from CUSA board and used 5200 adhesive to attach it into the compartment, and then the battery will sit in that, and then straps go over the top of the battery to hold it down. This shows where the battery remote on-off switch was mounted, just inside of the hatch in the cockpit, accessible from the helm station. That's just mounted inside of a plastic enclosure. This shows a arrangement of the equipment, not in its final position, to be able to do a function test for not just the battery but the propulsion system itself before all the equipment was moved into its final location and the cables tidied up. This view shows the E60 battery installed in the engine compartment and all the cables connected, and then you can see the straps on the left and the right that hold the battery down. This view shows the completed equipment arrangement for most of the propulsion system. The battery in the foreground, the driver module in the background, the big black box, the power head from the pod 3.0, and then the vent fan on the upper right that put a vent fan in there in case the driver module puts off enough heat to require some ventilation, and it vents back into the rear of the boat and takes air in from the vent in the front of the battery. This shows the area where all the propulsion equipment was installed, and the only sign of that anything's there is the intake vent, the black intake vent. So here we are with the boat in the water off the launch ramp, ready for the sea trials. Just some notes here about the results of the sea trial and using the boat with the electric propulsion. The electric propulsion seems to work, really well. Has plenty of power, to push the boat. At full throttle, 3,000 watts output, it'll push the boat about 5.1 knots. As far as the power of the E60, we have been using as little as maybe 10% of the battery capacity, just to motor out to where, we can put the sails up, and as much of maybe 50% of the capacity in the event that we motored almost 20 miles, at some reduced power, say 30%. So anyway, we've been out like 12 times now, and we're very happy with the electric propulsion system.